Alright, these are our notes for section 5, 5 roots of real numbers. We're going to start out with the parts of a root. And there are 3 parts to a root. They are the radical sign, the index, and then what's called the radicand. Alright, so those are your 3 parts: radical sign, index, radicand. If we look over here, we have the nth root of b. Now the radical sign is the check mark looking thing. That's the sign part. The index is n, and then the radicand is what's underneath the radical sign, so it would be b. Now, we have worked with in the past with indexes of 2, and you've probably not known that because we usually don't write it. And this is what we're familiar with. Okay, you've got 3 examples down here, and they're all square roots. Okay, if it's not written, the index, it's understood to be a 2, and that's what the star here is for. Okay, if index is not written, it's understood to be 2, which means we would have a square root, okay, which is something you're familiar with. So let's look at these 3 examples here. We have the square root of 81, square root of 49, and the square root of negative 25. And our goal for these problems is to figure out what number or numbers that we can square in order to get the radicand, in order to get what's underneath the radical sign. Well, for 81, we could square 9. That is one number we could square because 9 squared, really 9 times 9, is 81. There is also another number, and this is the one most people fail to realize. We could square negative 9. If we have negative 9 and we square that, we also get 81, because when we multiply negative 9 times negative 9, it becomes a positive. It becomes positive 81. So there's really 2 answers to that problem: positive 9 and negative 9. Our second example here is the square root of 49. Well, the same thing happens. There's 2 numbers that we could square. We could square a positive 7, or we could square a negative 7. And either one of those is going to give us 49. Now, another way to write that would be plus or minus 7. That is acceptable. That combines both the positive and the negative together in our answer. The last one here, the square root of negative 25, we want to come up with a number that when we square it, we get negative 25. Well, if we think about that, when we square something, it should always be positive. Okay, there is no number that we can square and end up getting a negative. So this is not possible. Okay, there is no root here for this last one, because there's no number or numbers that we could square and get negative 25. Now, it's not plus or minus negative 5, because when we square those, we get a positive 25, and we want the negative. So watch that. A negative underneath there, you may have no real roots as your answer. And again, if it's not written, the index, it's understood to be a 2, which would mean it's a square root. Now we're going to extend this idea a little bit, and we're going to change the index. And when we change the index, nothing's really different, except that we want to figure out a number that we could cube, or a number that we could take to the 4th power or the 5th power in order to get what the radicand is. We got 3 examples here. The first one is the cube root of 27. Well, what number can we cube to get the 27, to get the radicand? That's our goal. Now, you do have your chart. Okay, I gave you the chart in class and you filled it out. I want you to use that chart. Locate on your chart the cube column, because that's what the index is. The index is a 3. And look down there till you find 27. When you do, follow it over and figure out what number you can cube to get that. When you do that, the answer is 3. That is the only number that we can cube and get 27. Now, it's not plus or minus 3, because if we cube a negative 3, that's really negative 3 times negative 3 times negative 3. It becomes positive 9 times negative 3, which is negative 27. So it doesn't work. The only number that we can cube to get a positive 27 is 3. Our next one here is the cube root of a negative 125. So again, you want to look at the cube column because that's what our index is. Our index is 3, and we want to figure out what number we can take to the third power to get a negative 125. If we look at our chart, there's no negatives listed in our chart. The only numbers listed there are positives. So let's forget about the negative for a second. What number can we cube to get a positive 125? And if we look at our chart, the answer is 5. Now, since it's negative, we're going to make that a negative 5. Okay? Because if we cube a positive 5, that equals a positive 125. But just like in our first example, if we cube a negative 5, that's going to become a negative because the first two numbers, when we multiply them together, will make a positive 25. And then we're going to multiply that by another negative. So we do get a negative 125. So the answer for that one is a negative 5. The last one here, the fourth root of 81. Well, we want to look at our fourth root column. We want to figure out what number we can take to the fourth power to get 81. And if we look down that column, the number is 3. 3 to the fourth power does equal 81. 3 times 3 is 9, times 3 is 27, times another 3 is going to be 81. But we need to consider now whether we could take a negative 3 to the fourth power and still get 81. And if we look at that, negative 3 times negative 3 is positive 9, times a negative 3 would be a negative 27, times another negative 3. Well, you have two negatives now, so it is going to become positive. That does equal positive 81. So there's two answers to this one. Now, as we're working through those, you should see a pattern. Okay, those first set of examples all had even indexes. The second set, we had two that had an odd index, the index of 3, and the last one had an index of 4. If we look, the even indexes all have two answers. If my index was 2, I had two answers. A positive 9 and a negative 9, a positive 27, or a positive 7 and a negative 7, a positive 3 and a negative 3. If it was odd, I only had one answer. Okay, and that holds true throughout these problems. So if you have an even index, you will have two numbers, a positive and a negative, that you can take to the second power, take to the fourth power, take to the sixth power, and you will still get that number, the radicand. If it's an odd index, there's only going to be one, and it'll either be a positive number or a negative. There's not two. Now the exception is that square root of a negative 25, because we cannot take the square root of a negative. So that's the only one that's not going to have two numbers, and it has no numbers. Now there's a new idea here, and it's on principal roots. Okay, if there's more than one answer, so if we have an even index and we get two answers, that's what we're talking about here, and there's no sign given out front, no plus sign, no negative sign, no positive or negative, you only give the positive solution. Okay, I only want one, and that's called the principal root. Okay, it stands for the positive and the negative. Okay, but again, that's only if there's more than one answer and there's no sign given out front. We've got a set of examples here. The first one is the square root of 100. Well, again, if there's no index given, it's understood to be a 2. That's a square root. So we want to come up with the number or numbers that we could square to get 100. Well, we could square 10, and we could square negative 10. Now there's two numbers here. So this falls under that idea of principal roots. I have more than one answer, okay, and there's no sign given out front. There's not a plus or a plus minus out front. So you want to give me only the positive solution. So the answer to this problem is 10. Now again, there's really two answers, but you're only going to give me the positive one because that's the principal root. Let's look at the next one. Plus or minus the square root of 25. Well, we did this a little earlier with that negative 25, but this time the plus and the minus are out in front. Okay, that has no effect. It's not part of the radicand. So we want to come up with the one number that we could take to the second power and get 25. And you should know that by now. It's going to be plus 5 or minus 5. You only want to give me the positive 5 because there's a plus minus out front. There is a sign given. So there's my answer. The next one, the cube root of a negative 64. What number can you take to the third power to get a negative 64? Well, forget about the negative for a second. You could take 4 to the third power, and that'll give you a positive 64, but there's a negative under the radical. So the only answer you could have is a negative 4. Okay, now we don't need to worry about principal roots on that one because you only have one answer. You didn't get 2, you only have 1. So that is the principal root. You don't need to worry about just giving me a positive. Last example here, notice there is a sign out front. Okay, it's the negative square root of 49. Well, the square root of 49 is really 7 and negative 7, but we have the negative out front, so you only want to give me the negative answer. Okay? That dictates which root you're supposed to give me. You don't need to give me the principal one. You don't need to give me the positive one because it tells me that I want the negative. That's what the sign out front means. Okay? So principal roots, if you have more than one answer and there's no sign out in front, you need to give me the positive root. Okay, that's the principal root. Something to remember here at the bottom, if you have the nth root of 0, which means you could have any index you want, and 0 is your radicand, that is always going to be 0. Okay, and it works for any number n. Okay, as long as n is 2 or greater than 1. Alright? We have one more thing to talk about, and it is using variables. Okay, now I've got a question here for you. It says, how do you give the principal root of a variable? Because a variable could represent anything. You could put any number in there. We don't know what that number could be, because it'll tell us sometimes what number to plug in. We may not even know. Okay, how do you know what the principal root of a variable is, since it could be anything? And the trick is that we're going to use absolute values. Okay, because absolute values always give you a positive answer. Okay, remember an absolute value, if a number is negative, it just takes the negative away. So if we put a variable in absolute values, that means that it's always going to have to be positive. Now, you only need to worry about this. Okay, only need to worry about it for an even index, because those are the ones that give you two answers. If I have an odd index, it's got to be one or the other. It'll be positive or negative, so we don't need to worry about that. We just have to worry about it if there's an even index. And there's a second part here, and your answer has an odd exponent. Okay? Only if it's an even index, because that yields your two answers, and if the answer, when you work it out, has an odd exponent. If your answer has an even exponent, it's always going to be positive. If you square a negative, it's going to be positive. If you take a negative number to the fourth power, it's going to be positive. So you only need to worry about it if the index is even to start with and your answer is odd. Now, you also need to consider if there's no sign given. Now, if there's a sign given, you don't need to worry about this. It's going to tell you whether it needs to be positive or negative. Okay? It's if there's no sign given, even index, odd exponent on the answer. Let's look at some examples here. We have 7 of them. Okay? First one here. Notice we have an even index. It's the 6th root of x to the 6th. Okay? Even index. We want to look here. I'll give you a trick for exponents and variables underneath the radical. If you know the index, you're just going to divide it into that exponent underneath. So 6, this 6, divided by your index is 1, which means we would have x to the first. Okay? Again, I'll say that trick again. Whatever your index is, you take the exponent underneath and divide it by the index. So 6 divided by 6 is 1, and that becomes the exponent on our answer. Now, we had an even index. The exponent on our answer is odd. That's 1 is an odd number. So according to our rule, we need to put this in absolute values. Okay? We have the absolute value of x. I'm going to rewrite that over here because you don't need to write that exponent of 1. You have the absolute value of x, because that x could be positive or negative. The even index tells us that you could have both answers, a positive answer and a negative answer. So we have to put it in absolute values in order to make sure that it's positive. Let's look at our second example. It's the square root of 25x to the fourth. Now remember, there's no index given. We understand that it's a square root. 25 is a perfect square. The square root of 25 is 5. I'm going to write my 2 in there just to help me, so you can use this shortcut again. Okay, 2 is our index, 4 is the exponent under here. 4 divided by 2, the exponent divided by the index, that's 2. So we would have x squared. Now we did have an even index. Okay, so we have to check and see if we need absolute values. We don't, because our exponent is an even number. It's 2. So this is the answer to the problem, 5x squared. Since it's an even exponent on our answer, no need for absolute values, because whatever we square there, whatever number x is, it is always going to be positive when we square it. Let's look at the next one. You have the fifth root of 32x to the 15th, y to the 20th. Alright, we need to figure out for the 32 first. What number can we take to the fifth power in order to get 32? Well, that's 2. We could look at our chart and figure that out. Now let's look at the exponents. We have 15 on the x, and we're going to divide that by the index. 15 divided by 5 is 3, so this is x cubed. And then 20 divided by 5, that's 4, so it's y to the 4th. Now I want you to think, do we need to put absolute values on this? Because we do have an odd number exponent. The answer is no, we don't need to, because we didn't have an even index to start with. Okay, you only have to worry about absolute values if you started with an even index. So there's our answer to the problem. Since it's an odd index, no need to worry about absolute values. Next one, the fourth root of 81 times the quantity a plus 1 to the 12th. We need to start with the 81. Okay, what number can we take to the fourth power to get 81? We did this problem earlier. The answer is 3. Okay, if you forget, go back and look at your exponent chart, and that will help you. Okay, 3 to the fourth is 81. Now we have an exponent out here over a set of parentheses. That doesn't change anything. Use it all together. We're going to take 12 divided by 4. 12 divided by 4 is 3, so we have a plus 1 to the third. Now, we have an odd exponent on our answer. We had an even index to start with, so all of this, just this part, just the variable part, needs to be in absolute values. Okay? The 3 doesn't get included. This stays where it's at. Just the variable part with the exponent gets put in the absolute values, because that's what we're worried about. We want that part to be positive. Okay, so I'm going to rewrite the answer over here. 3 times the absolute value, a plus 1 cubed, okay, and then that closes our absolute values. That's the answer to our problem. Our next one here, we have the negative square root of the quantity y squared plus 2 to the 10th power. Notice there's no index given, so we understand that it's a 2. We also have a sign out front, okay, which means we're going to have a negative answer. Since it's all in the parentheses together, we're just going to worry about that 10, and we're going to take 10 divided by 2, which is 5. So we have y squared plus 2 to the 5th power. Now since we had that negative out in front, we need to bring it out in front over here. Now, since the sign was out in front, there's no need to worry about the absolute values, because it tells you that you only want the negative value, the negative root. Okay, that's what the sign out front means. Since there was a sign given, even though we had an even index and we have an odd exponent on our answer, we still just leave it the way that it is because the sign's out front. You have 2 more problems here. I'm going to leave these for you. These are going to be your pause and practice problems, both of them. Okay, I want you to pause this pencast, work them out, and then come back and check your answer. Alright, let's look at this first one. The square root of 36a squared b to the 4th. Well, again, the index isn't written, so it's understood to be a 2. We can add it in there if we need to. We want the square root of 36 first. That's going to be 6. We should know that. Now we take the index and the exponent. We're going to divide them. Exponent on top, index on bottom. 2 divided by 2 is 1, so it's just a to the first. And you don't need to write the 1. I put it in there just so you can see where it's coming from. And then you have b to the fourth, so we have 4 divided by 2, which is 2, so b squared. Now you started with an even index. You do have a value with a negative, or not with a negative, with an odd exponent. So that has to go in absolute values. And just that. Okay, b squared doesn't because we know that's going to be positive. So I'm going to rewrite the answer over here. 6 times the absolute value of a, and then b squared is not in the absolute values. And there's our answer. The second pause and practice here, the cube root of 125 a to the 6th b to the 12th. Well, we did this first part a little earlier, something similar to it. We went what number we can take to the third power to get 125. Well, that's going to be 5. And then we're going to take the 6 on our exponent on our a and divide it by 3, and we get 2. So it's a squared. And then 12, the exponent on our b, divided by 3, and that is 4. So b to the fourth. Now we had an odd exponent to start with, so there's no reason to worry about absolute value signs. So that's just going to be our answer. 5a squared b to the fourth. Now I know the absolute value part is tricky. It's something that you need to practice. Just remember that it only applies if you started with an even index and have an odd exponent on your answer, and that there's no given sign out in front of your square root or your cube root or your fourth root, okay? No sign can be out front because that'll dictate what you're supposed to do. Those are your notes on section 5.5, roots of real numbers. I know it can be tricky, but you need to know it all.